Welcome back, Dr. JC here. Part 2, Lesson 2. We're going to talk specifically in this lesson about the impact of the Industrial Revolution, this second Industrial Revolution, on the United States, specifically these various movements like the efficiency movement and scientific management. The second Industrial Revolution is a little bit different from the first, largely because we're going to see two new industrial powers emerge, one being Japan, the second, the United States. In the previous lecture, we mentioned that industrialization was dependent upon four factors. Those four factors were global networks of finance, trade, resource extraction, and demand. Now, before we move into efficiency movement and scientific management, the focus of this lecture, I wanted to pause for a minute and talk about three conditions that really are necessary ingredients for industrialization to occur within a society or within a nation state. Those three are listed here on this slide. One has to do with the introduction of a new technology. There has to be some sort of new thing, a new game changer that in some sense is going to drive further desire for increased automation. The second has to do with advanced capital formation. You have to have a system or series of central banks, venture capitalists. And you say, well, wait a minute, what's a venture capitalist? Venture capitalists would be kind of like those guys that you would see on the cable program Shark Tank, right? These are individuals that have money and are willing to invest in people's ideas, people that might have great ideas and great products but don't have the means to bring those products to market. So you have to have financial backing, stable financial backing. And the third point, perhaps maybe the most important ingredient, is political stability. You have to have a society that is relatively stable. Example, 2018 example. How many of you today would like to set up a new business in Damascus, Syria, in the midst of an ongoing civil war, in the midst of the region of social, political, religious upheaval? Or would you want to set up a business in the United States, Canada, or Great Britain? Areas that, yes, they have some political unrest at times, but by and large, very stable, peaceful systems. Which would you choose? So these three are necessary conditions for industrialization to occur, and I want you to consider those as we move forward. As it relates to industrialization in the United States, I'd be remiss if I at least didn't give some rhetorical nod to Eli Whitney and perhaps even Henry Ford, especially as it relates to systems of interchangeable parts, the creation of a system of interchangeable parts, the use of an assembly line, those things that we'd associate with the manufacturing environment today. But I wanted to start our focus here on the gentleman depicted on this slide, Frederick Winslow Taylor. And Taylor was interested in looking at manufacturing environments, applying some left brain or some science to what he was seeing in the manufacturing space, and look to develop patterns of productivity and efficiency. Through his own observations, whether they be in the steel industry or other industries, Taylor recognized that most workers in these manufacturing environments, they tended to do what he called soldier. And by soldiering, what he meant is the workers would just kind of plod along as the assembly line or production was in place. They didn't seem to move with a lot of heart, didn't move with a lot of alacrity. They didn't seem too interested in what was going on. And as a result of that, he figured that, heck, there's an opportunity here. If we can get employees more interested, maybe provide them with greater incentives, that maybe they'll move faster. And if we can move faster, then we can go ahead and turn up the line speed, and with increased line speed we can improve the number of pieces that are being put out on a daily basis. And ultimately what he's looking for is not only increase productivity and efficiency, but profitability, right? So with clipboard and stopwatch in hand, he begins to develop this series of studies that we could call time and motion studies today. And time and motion studies, for all intents and purposes, were a way to look at each individual process on an assembly line and break down that process according to the amount of time it takes an operator to complete that process. The goal then was to identify different areas where there might be wasted motion or wasted effort and look to eliminate those areas of waste to ultimately achieve much greater efficiency. And while looking at each individual operation, he could then balance the operators that are side by side. For example, if it took operator A 45 seconds to do her or his job, and it takes operator B a minute to do her or his job, there's a 15-second discrepancy between the two. Clearly, operator A is going to be able to complete her or his process much faster than operator B. As a result, operator A is going to be doing what? Piling parts on operator B. It's going to stress out operator B. It's going to cause the need for perhaps racks to be built so all these extra parts can be thrown on those racks. All of that's waste. What Taylor would say is, look, rather than having operator A work at 45 per operation and operator B at 60 seconds, let's find a midpoint between the two. There might be some aspect of the operation operator B is doing that we can transfer to operator A and balance those two operations out, thus looking for ultimate efficiency. While time limits the amount of granularity we can give to Taylorism, one aspect I did want to focus on here, a shortcoming as it relates to Taylorism, was the nature of the system itself in design. It was designed to be driven by folks from the top. The line workers themselves were not included in the process. Therefore, it was the engineers, the folks, quote unquote, with the white collars that were going to come out and tell the folks with the quote unquote blue collars how it was that they should better do their jobs. So one of the salient shortcomings with Taylorism is that they didn't involve the frontline workers. They didn't involve the workers themselves. And we'll see that change as the century continues, as we move from the early 1900s more to the modern early 2000s. As we move out of the 1920s and 30s and 40s into the 50s, 60s, and 70s, we see individuals like the gentleman depicted here, Dr. W. Edwards Deming, Ed Deming, wanted to build on what he found to be some of the impurities in the scientific management approach. Again, he recognized himself the salient shortcoming in Taylorism, which was the lack of involvement in frontline workers, the friction between laborers and management, between unions and management. And he felt like, look, a more cooperative environment needs to be put into place here if we're really looking at wanting to put out a perfect product for the customer. And therefore, Ed Deming starts to come up with some different systems of his own. One such is depicted here, this PDSA cycle, or Plan, Do, Study, Act. It really is a model for continuous improvement. It's a model for individuals within a manufacturing environment, whether they be frontline workers themselves, the laborers, or management, to look at every process within that facility and look for ways to do it better and more efficiently. The goal at the end of the day of all this is to try to get rid of all of the defects, all of the waste in various processes. Because if you can get rid of the wastes, you're working at a much greater efficiency level, the productivity will be better, and ultimately quality will be better. And quality will then equal what? Better product reviews from customers and the greater likelihood that other customers are going to share their experience with their friends, and greater use of and purchase of those products moving forward. So once you get a customer, you want to keep that customer. And the Plan, Do, Study Act was really based on that idea. Ed Deming's work ultimately opened the door to what we might consider lean manufacturing today. Lean being the more modern scientific management, where rather than this being top-down driven, the change in continuous improvement is actually driven by the frontline workers themselves. That the workers themselves have greater command and control of sorts of their own operations. How can we do this more efficiently? How can we do this more easily? How can we do this more ergonomically? And therefore Ed Demings really did sort of flip that old business pyramid where the smart guy sat at the top and everyone else beneath him or her followed the rules. No, no, no. In the modern age, it's the frontline workers that are going to be the ones that are driving change. And therefore Ed Deming's work really was transformative. In Lesson 4 ahead, we'll build off the work of Ed Demings when we start to talk about the change in corporate structures and mindsets as it relates to continuous improvement. We'll look specifically at corporations like IBM and Tom Watson that ran that organization, and how his mindset built from these existing systems that came before him, whether they're Taylor's system or those from Ed Deming. So we'll talk more about this in Lesson 4 ahead. But as a little foreshadow to Lesson 3, where we turn next, in Lesson 3 we're going to focus specifically on industrialization's impact on society and the environment within the United States. That's where we'll go next. Dr. JC out here, Lesson 2. Look forward to plowing into Lesson 3 with all y'all.